Okay, so in our second video, we're going to talk about something called the vertex of a parabola. So in our last video, we talked about when a quadratic function looks like ax squared plus bx plus c, then the number a is going to tell you whether it opens upwards or opens downwards. And it's basically just going to be as a positive or as a negative. What we want to talk about now is, where am I supposed to put that at? Is it supposed to be centered at the origin, 0, 0? Is it supposed to be centered at some other place? That's actually going to be what the vertex tells us. So the vertex is the tip of the parabola. So as an example, if we have a parabola shape, that's a pretty wonky parabola shape, but the vertex is going to be the tip, the point where it switches from going up to going down, or going down to going up. So this would be the vertex, and that would be the vertex. So this little dot that I put in is the vertex. So if I tell you the vertex, and you know A is positive or A is negative, so which of these two shapes is supposed to be, the vertex would tell you what point this is supposed to start at. So I should have emphasized that. I'll emphasize it now. The vertex is going to be the point. So it's going to be x comma y. So let's look at an example. Sketch the parabola with A is equal to 2 and vertex 3, negative 1. Okay, so if I start with my graph, the point 3, negative 1 is my tip. A is positive, so A should be opening upwards. It should be generally this shape, and this should be the tip, so it should start here, so going up in both directions from that point. And this may not be a super accurate graph. I wasn't paying a lot of attention to what A was. Theoretically, A being 2 as opposed to 1 would tell you how narrow or wide the parabola should be. But if we just want a quick version of the graph, this is good enough. Starting with the vertex, and then positive means we're going upwards. If A had been negative, we would start at that point and go downwards. Okay, as another example, find the vertex. Of the following parabola. Man, I did a terrible job of generating random numbers. But the vertex of this parabola would be the tip, which appears to be this point. And so given the graph, it would be that point, which is x is equal to 3, y is equal to negative 1. So terrible job generating random numbers since I generated the exact same point. Anyway, you'll notice in any case that this picture has an A as a negative number. But if I did give you a shape, like drew another graph, let's try another one. And you'll have to deal with my depressing lack of art skills. If we try and spot the vertex, it's not really clear because this is kind of a wobbly shape, but we'll call it that point, which is x is 1.5, y is about 3. So the vertex would be the point 1.5, comma 3. Something I should note, my graphs are all a terrible example of this, but all of your parabolas should be symmetric. So if I draw a dotted line straight through the vertex, it should be symmetric left to right. And I don't know that any of my pictures is really doing that. The book calls this the axis of symmetry. It's the dotted line around which the graph is symmetric. This one maybe does a little bit better. The left and the right sides are symmetric copies of each other. Okay, anyway, that's the idea of the vertex. If we are able to find some way to calculate the vertex, which is going to be the topic of a later video, then we should be able to figure out where does the graph start. And given a graph, we should be able to find the vertex. Okay, so the graph and the vertex are somewhat importantly connected.